In this video, I'll showcase the industry's first 5G advanced signal analysis capabilities of the Keysight 89600 VSA. 3GPP Release 15 laid the foundation for 5G NR, providing the essential building blocks for all follow-on releases. Releases 16 and 17 added enhancements and features in different areas, and Release 18 marks the start of 5G Advanced, a significant step towards 6G. One major enhancement in 5G Advanced is the evolution of MIMO, improving both multi-user MIMO and single-user MIMO. For multi-user MIMO, it doubles the maximum number of antenna ports or layers from 12 to 24, significantly increasing capacity by enabling a larger number of devices to be served simultaneously. For single-user MIMO, uplink spatial multiplexing is expanded to support up to 8 transmission layers, doubled from 5G, and now matching the downlink's single-user MIMO capability. In this 89600 multi-user MIMO example, 3 simultaneous users use the same time and frequency resources, each with 8 antenna ports or transmission layers, with a total of 24 ports. This, for example, could also be configured with 24 users, each with a single antenna port. The key point here is that the maximum number of antenna ports is expanded to 24 for multi-user transmission purposes, while a single device can transmit or receive up to 8 antenna ports or layers. For this example, each port is mapped to 64 physical antennas for beamforming. The VSA supports up to 64 measurement channels, with each channel corresponding to 1 physical antenna. For live beamforming measurements, the VSA is used with Keysight's NTRX hardware. It is the industry's first and only hardware with up to 64 phase and time coherent input channels. The VSA can also be used for offline analysis using IQ data files with various file formats, including MATLAB. Coming back to the multi-user MIMO demo, the VSA software offers a comprehensive set of measurement results for verifying and visualizing MIMO and beamforming signals. Shown here are just a few of the available traces. The constellation diagram provides a quick visual check of signal modulation quality. It can be displayed as a composite of all layers, or it can be viewed per layer. The detected allocations trace allows visualization of time and frequency allocations for each user. The MIMO info table reports matrix and impairments for each antenna port, including EVM, power, time alignment error, frequency, and phase offset. The beam weights trace shows the measured beam weights for each of the 64 physical antennas, both in magnitude and phase, allowing verification of the beamforming algorithm. The 3D plot visualizes the resulting beam pattern from these weights. As mentioned, 5G Advanced also enhances single-user MIMO in the uplink, increasing the maximum number of spatially multiplexed layers from 4 to 8. Here, I have an uplink example with a single user utilizing 8 spatially multiplexed ports or layers for 8x8 MIMO. The same set of measurements available for multi-user MIMO is also available for single-user MIMO. Since the signal has channel encoding, you can decode it to obtain CRC information. In addition, I am showing the frame summary trace with per layer EVM. Another key enhancement in 5G Advanced is extending 5G to vertical industries such as railways and public safety. Prior to Release 18, the smallest carrier bandwidth for 5G NR was 5 MHz, with some sectors having a dedicated spectrum of less than 5 MHz. 5G Advanced reduces the smallest bandwidth to 3 MHz. To support such use cases, the 89600 VSA supports the 3 MHz bandwidth as shown here. The VSA can be used to analyze signals from the smallest bandwidth of 3 MHz in FR1 to the highest bandwidth of 2 GHz in FR2. In summary, the 89600 VSA software delivers the industry's first 5G advanced signal analysis, leveraging its leading-edge capabilities for advanced technologies, including 6G research. To learn more and download a free trial, visit our website.